This video covers the connectivity page of the ACEP Advanced Telemetry portal. The connectivity page presents a real-time operational view of ACEP's communication architecture, spanning deep space data return to Earth and local line-of-sight links to deployed assets. The page aggregates panels for SKOJITOX deep space transmission, LSCS Ka-band and X-band links with RF channel and link budget analysis, relativistic one-way signal delay, ACEP Atmos power and communication interfaces, and automated telemetry report management. The SKOJITOX Link panel presents live telemetry of the SKOJITOX Deep Space Laser Communication System. SKOJITOX is the operational name for the Chinese system designated Shenkong Jiguang Tunxin Xitong, meaning Deep Space Laser Communication System. The upper status bar reports the current transmission cycle state, accumulated payload volume, remaining data for the cycle, and time to the next scheduled transmission window. Transmission cycles occur at fixed 5-hour intervals. Two independent laser emitters, A and B, are shown in parallel. One emitter operates nominally, while the second remains in hot standby for immediate takeover if geometric or pointing constraints are encountered. For each emitter, the panel displays achievable transmission rate and optical beam divergence. The rate represents instantaneous throughput capability under current link geometry. Beam divergence characterizes optical collimation and directly limits link margin. Emitter pointing is expressed as azimuth and elevation relative to the commanded Earth vector. Polar displays indicate the active bore sight direction and expose mechanical or elevation limits that inhibit transmission. Pointing stability is tracked through a short window angular error trace. The numeric error value reports instantaneous off-axis deviation in microradians and serves as a direct indicator of tracking quality. Link integrity is summarized by bit error rate, encryption state, and signal-to-noise ratio. Together, these parameters confirm whether the optical link satisfies reliability and security requirements for high-volume telemetry return. The LSCS Antenna Systems panel presents live telemetry of the local space communication system used for short-range, line-of-sight communication with ACEP Atmos and potentially other nearby assets. The panel reports the real-time operational state of the Ka-band high-gain dish and the X-band omnidirectional antenna, which provide complementary local communication paths with different performance and robustness characteristics. For the Ka-band system, the panel displays antenna pointing as azimuth and elevation. The polar orientation display shows the active bore sight direction and exposes mechanical, elevation, and line-of-sight constraints that determine link availability. A line-of-sight indicator reports whether the directional link is geometrically viable. For the X-band system, the panel reports connection status for the omnidirectional link, which remains tolerant to pointing and attitude changes and provides continuous low-rate connectivity when available. For both Ka-band and X-band, the panel shows live uplink data rate and transmitter power tracked over a 60-second time window. Step changes in rate and power reflect link acquisition, modulation activity, and control loop response as geometry evolves. The LSCS Channel Map panel presents a real-time spectral and link budget view of the Ka-band and X-band local communication channels. For each band, the upper display shows the received spectrum centered on the nominal carrier. Spectral amplitude is expressed in decibels and represents instantaneous occupied bandwidth and signal power distribution. The vertical marker indicates the predicted Doppler shift caused by relative spacecraft motion. Below the spectrum, usage reports the current fraction of available channel capacity being utilized. Target rate defines the nominal configured data rate for the link. Modulation indicates the active waveform, with higher-order schemes used for Ka-band efficiency and robust schemes used for X-band stability. Average SNR reports the mean signal-to-noise ratio over the measurement window. Negative values are nominal for wideband coded links and do not indicate degraded operation. Noise floor represents the estimated baseline receiver noise level and is expected to be negative on an absolute decibel scale. Tsys is the receiver system noise temperature in Kelvin. G over T expresses antenna gain relative to system noise temperature and defines receiver sensitivity. Free space loss reports geometric path attenuation based on range. Pointing loss quantifies signal degradation due to antenna misalignment. Doppler predicted reports the expected carrier frequency offset. The sign indicates shift direction only. C over N0 predicted expresses carrier to noise density, reference to 1 Hz bandwidth, and is the primary determinant of demodulation capability. Negative values are normal at long range. Margin at R reports link margin at the target rate. Large negative values are nominal and are used for trend monitoring rather than absolute validity. AFC offset reports residual frequency tracking error after automatic frequency control. AGC headroom indicates remaining gain margin before receiver saturation. RFI events count detected interference occurrences within the observation window. The lower graph shows 1-minute channel load, reflecting short-term utilization dynamics. All parameters are evaluated continuously and reflect the instantaneous physical, geometric, and RF state of the LSCS links. The TX delay panel visualizes the evolution of one-way electromagnetic signal propagation delay along the relativistic trajectory of ACEP. The horizontal axis represents mission time measured in spacecraft proper time. The left vertical axis shows one-way signal delay in days. The right vertical axis shows millisecond scale delay used during ACEP Atmos operations. Curves labeled ACEP to Earth show telemetry delay measured in the spacecraft proper frame and in the Earth inertial frame. The increasing separation between these curves is produced by special relativistic time dilation accumulated during sustained high-velocity flight. Curves labeled Earth to ACEP show command latency from Earth. In the Earth frame, this delay asymptotically approaches a constant value as ACEP nears the Proxima system, reflecting the fixed Earth to Proxima separation imposed by light cone geometry. Curves labeled ACEP to Proxima and Proxima to ACEP show one-way delay reference to the Proxima system rest frame. These delays decrease as geometric separation closes during terminal approach. A vertical marker indicates the current mission epoch and can be moved to inspect historical signal latency, with exact values reported in the legend. All values are derived from live mission geometry and relativistic kinematics and represent the true causal communication latency. The Atmos Link panel presents the real-time power and data interface between ACEP and the ACEP Atmos probe. Atmos is shown as a self-contained payload probe, electrically supported by the mothership through the dock interface prior to release. Before separation, Atmos batteries are charged from the ACEP power system via this connection. The Power Distribution Center, PDC, serves as the primary electrical interface. It routes power from the ACEP dock to the system bus and reports the live state of charge of the probe's batteries. After separation, all Atmos avionics and instruments operate exclusively on internal battery power. Data handling and performed by the Command and Data Handling System, CDH. CDH aggregates payload telemetry, power and health data, and attitude data, then time tags, packages, and routes all data to the radio frequency subsystems. The system bus supports core avionics functions, including attitude determination, inertial sensing, and RF subsystem interfaces. The payload bus aggregates all scientific instruments carried by Atmos. The payload list on the right enumerates all active instruments, each generating telemetry routed through the CDH. The panel represents a live, functional map of electrical power state, data aggregation, and communication routing governing Atmos operations before and after probe release. The report summary panel shows the state of report collection for each telemetry domain. Each row corresponds to a telemetry category. Colored bars indicate the completion state of data accumulation for 4 reporting timeframes: monthly, weekly, daily, and laser transmission cycle, corresponding to the SKOJITOX reporting window. The Report Settings panel controls the configuration of automated telemetry reports generated from the ACEP data stream sent directly to the operator's email address. The panel shows the delivery address status, global report enable state, and the selected reporting cadence, with options for daily, weekly, or monthly dispatch. Content selectors define which telemetry domains are included in each report, allowing the operator to scope summaries across navigation, propulsion, energy, connectivity, ORI, survey data, and notifications. The lower timing fields report the elapsed time since the last report and the countdown to the next scheduled dispatch, providing direct confirmation of report scheduling and system activity. An example of a generated report built from the currently selected content and report cadence is shown on screen now for reference. Reports are delivered in a plain text format, optimized for rapid reading and unambiguous assessment of the spacecraft's current state across all telemetry domains. In summary, the connectivity section provides a complete, real-time view of ACEP's communication capability, ACEP Atmos data flow, relativistic signal latency, and reporting readiness across both interstellar and local operational domains.